Hi everyone, today we are going to learn about one to many and many to one. So, one person can have more than one car, and one car can have only one owner. So, this is the relation which we are going to look at it. From person to car, it is a one to many, and from the car to person, it's a many to one. So one person can have multiple cars. So that's the reason we are using set of cars. But in case of the car can have only one owner. So that's the reason we gave as one person object. So how we are going to create the relation from person to car? So for this one, as I mentioned, one to many. So one to many. As part of the one to many, we need to provide all the necessary information. So I'm giving the fetch eager and cascade. It's the same as one to one. They are all cascade properties are same. So currently I'm giving as all. And the next I'm giving the R1. Whenever we set the cars as empty, then it's going to delete all the cars. So in real time, it is not required, just for our demonstration purpose I am showing it here. Now let's go back to our start program. As part of the start program, I modified the code and I entered already some piece of code to save the time. Here the person object has been created and the person object saved and it's been printed. If you look at print person by ID method, so we have the person ID and we are printing all associated cars. And in case of the cars, we created a set of cars and we have added cars. And while creating the car object, we are passing person object as well into that. So as part of the construction of the car, we are sending the owner as well. This is required for the bidirectional, but for now I'm adding it. Okay, and after that we are setting the cars and the person and saving the person. As part of the cascade all, along with the person, cars also will get saved into the database. And after that I'm calling the print cars by ID. As part of the print cars by ID, we are calling print car by ID. As part of the print car by ID, we are printing car and the associated owner. And after that, we are deleting the person object. When we are deleting the person object, the associated objects or the relationship will be deleted as well. After that, we are printing the person and the cars. We have a person object and we are creating the car objects with association with person, but in the car I made a little modification. For the person I made it as a transit, otherwise we will get an error while running it, because person is the object, not a primitive data type, so it will expect relation should be proper. So that's the reason added as a transient for now, and while demonstrating the bidirectional then we will remove it. We are capturing the person also at car creation. After that we are adding all the cars to the person and then we are saving it, printing the person, printing the cars one by one, and after that we are deleting the person. Then we are expecting all associated cars will be deleted as well. So let's run the application. So first we look at the table. So the car table has been created. So it has all the necessary properties as we defined at the entity, and person table has been created, and there is an additional table that was created just to maintain the association, which is a person TB cars. So it has the car ID and the person ID and the primary key composite of both car and person IDs. And after that, while saving the person, it is saving the car as well. After that, it is updating the relationship in the person TB tables. And while fetching the person, we got all the cars as well. Here is the person, and after that we got all associated cars. And next we are fetching the car by ID. So at that time car has been fetched, but the owner information is null because we don't have the bidirectional one. So car is individual entity for now. So this is unidirectional from person to cars. So that's the reason person has cars list, but the car doesn't have the person information. So like that 1, 2, 3, all three cars has been mentioned, and after that we deleted the person. When we deleted the person, so it deleted the relationship and the individual cars and finally the person as well. When we are fetching details after deletion, we are getting no person, no car data. So now let's implement the bidirectional. Now let's look at the bidirectional. In this case, I want to fetch the owner information from the car as well. So here we need to create many to one. Many to one. And here we need to mention the cascade and fetch type as eager. That is all we need to do to get the owner information from the car. So save all of them and run the application. So let's check the creation of the tables. In the creation of tables, we have the car table and the person table, and there is an additional table is being created as we expected, person TB cars. And here we have both car ID and person ID and the primary key, which is composition of car ID and person ID. So while saving the data, it inserts the data into the person table and the car table, and the relationship is maintained at person TB cars table. And while fetching the person ID, we got the person object, and from the person object we got the car information as well. So this is, we already discussed, one direction from the car person to cars, that means one to many. And now the bidirectional one. So while fetching the car, we got the car information. From the car we extracted the person information as well. This is bidirectional, from many cars to one. So one car has one person association as a owner. So it's the same for the car 2 and car 3 as well. And while deleting the person object, as we have set the cascade as all, it's going to delete cars also. So first it deleted the relationship and then individual details from the car and the person as well. And while fetching the details later, we got no person data and no car data as we expected. If we observe, we are maintaining a separate table to maintain the relationship. So is this required? Is this mandatory? No, it is not mandatory. There is another way to do it. So in case of the one to many, here if I provide another property mapped by, and I need to provide where exactly this is mapped to. It is mapped to owner. So if I give this information over here, now the additional table will be removed and the person information will be added to the car. So in this case, the person ID will be added to car object. So let's save all the files and rerun it. If you observe it, we have the car and the person. Now there is no table which maintains the person and car relationship. Instead of it, it created owner ID inside the car table itself. This is how it maintains the relationship from the person to car or car to person. So rest of things is exactly the same. While saving the data, here it saved the person data, and while saving the car, it passed the owner ID. That's the reason the person insertion is first. So after fetching the person ID, and it's updating as a owner ID in the car table, and after that while fetching it from the person data to, we got the car information. From the car information we got the person data as well. So this proves that bidirectional is successful. And while deleting it, we deleted the person object, then the car information has been deleted first and then the person object. And while fetching the data after deletion, we got no person data and no car data. If we need to maintain the relationship in a separate table, then we should not give the mapped by. Otherwise, we can go with mapped by. That means sometimes we need to create the associations as part of separate table, then no need of mapped by. And can we customize the table name which is going for the mapping? Yes, we can do that. That can be done using the join table. So in the join table, I need to provide a set of properties. So let's check the one. First one, name. In this case, I am giving person, car, mapping. And here I need to give the join columns. As part of the join column, I need to create join column. And the first one is a name. So here I want to give as a PID for the person ID. And we need to give the reference column name. So in this case, the reference column name is ID. So I need to give ID. While entering the bidirectional information, we need to use inverse join columns and provide the join column. So here the name is CID and reference column name is ID because we used the ID even for the car. So now if I save all the files and rerun the application, then we will have a separate table for maintaining the mapping as we seen in the first and second scenarios. So let's go to the create tables. In the create table, we have the car and we have the person, and we have another table, person car mapping, which we have created using a additional annotation, which is a join table, and where we have given the name. So PC naming, and after that we have given the PID for the person ID and CID for the car ID, and there is a primary key which is composed of PID and CID. Rest of things are exactly the same as, so it has the insertion into the person and then car, and later it's inserting into the mapping table, and it has both from person to the cars, from the car to person, all the information is there. While deleting it, it deleted the first mapping and then the car and then the person, and after that while fetching the data we got the no person data and no car data as we expected. So this is how we are going to maintain one-to-many and many-to-one relationship. Thank you.